Lesson 18. Okay, so you remember last time, lesson 17. Give me a pencil. Yeah, lesson 17, which was sig figs and scientific notation. Well, learning the sig figs is truly important. You want to always express your measurements and your answers with appropriate numbers of sig figs. Don't throw extra digits down just because your calculator shows them to you. And also don't round off too much. You know, if you got 4 sig figs, maybe use 4. But I made an agreement. I said, you know, just to keep things easy in this course, and you could apply this to, I believe, most of your electrical career, we can just agree to use 3 sig figs always. Measure everything to at least 3 sig figs. When you work out an answer, report your answer with at least 3 sig figs. And I said if you put the calculator in scientific mode with 3 decimal places, then you'll always have 3 sig figs. The calculator takes care of it all for you. Now, here's the thing. What I should have said is not 3 sig figs with scientific mode, but 3 sig figs with scientific mode, but using engineering notation. So there's an extra step involved. It's called engineering notation. So what is the difference between scientific notation and engineering notation? Well, I'll show you right here. Here's a nice number. 1, 2, 3, 4, 5. 12,345. That's just standard form, normal form, whatever you want to call it. If you want to go to scientific notation, remember what we did? We put the decimal right after the first digit. So the first digit's a 1. You put the decimal right between the 1 and the 2. And so you go 1.23. And since we're going to round to 3 sig figs, you look at the 4, and the 4 says, oh, round down. So I'm going to leave it as a 1.23 times 10 to the, and it looks like, let me get this stuff out of the way, it's, oh, you bother me. Okay. It looks like if I'm going to put the decimal here, when really it's supposed to be over there, it looks like you have to give the person instructions that the decimal isn't really after the 1. Really, it's over here. Go to the right. 1, 2, 3, 4 places. 4 places. 1.23 times 10 to the 4th. So that is your scientific notation. It's number dot number times 10 to a number. And the only real restriction is you don't start with 0. Just don't start with 0. As long as you don't start with 0, you go number dot number times 10 to the number. Everything's fine. You're in scientific notation. But that's not an engineering notation. No, it is not. I'll show you what engineering notation is. Actually, you know what I'm going to do? I'm going to show you something really cool. Head over to your calculator. There it is. Okay, and now I'm going to hit the on button. That's always a good start. I'm going to like hit it hard. There we go. And remember that number 1, 2, 3, 4, 5? Well, notice your calculator, since I have it set up in scientific notation with 3 sig figs. And by the way, how did I do that? In case you missed the last lecture, you go here, Shift, Setup, you use 7 for scientific notation, and then you choose how many sig figs you want. And I still haven't figured out what 0 sig figs means. But anyway, we want 3 sig figs, so you type the 3. So Shift, Setup, 7, 3. Now you're in scientific notation. And now if you enter a big old number like 1, 2, 3, 4, 5, and you hit equals, it says, hey, didn't you want 3 sig figs scientific notation? Yeah, that's the way you set up your calculator. So there you are. That's the number with sig figs and scientific notation, just like I showed on the notes. Okay. New button. So we get this thing called engineering notation, right? You see this thing that says ENG? That means engineering notation. So you go like this. Boom, just hit it once. And it changes it. It's not 1.23 times 10 to the 4th, it's 12.3 times 10 to the 3. So let's go back to our note sheet. So engineering notation is 12.3 times 10 to the 3. That is engineering notation, or at least closer. 12.3 times 10 to the 3. You have to use these prefixes for it to be complete. But for now, 12.3 times 10 to the 3. Engineering notation. What's the significance of engineering notation? Exponent is a multiple of 3. It has to be a multiple of 3. A 3, a 6, a 9, a 12, a 15, an 18, a -3, a -6, a -9, a -12, a -15. All of these are acceptable. They have to be a multiple of 3. So you can't just take the 4 and make it a 3, right? You have to move the decimal. So the way you might look at this is, hey, in scientific notation, we were going to have to slide the decimal 4 places to the right because of that 10 to the 4th. Multiply by 10 4 times, you'll slide the decimal to the right 4 times. So if I slide it to the right once, then I've only got 3 to go. Get it? I already did 1, so I've only got 3 to go. And so that's how we justify writing this with a 10 to the 3, is we have to actually make that a 12.3 times 10 to the 3. Now, to be completely done with engineering notation, what you'd really have to do is you'd have to go like this. Times 10 to the 3? Oh, look that up down here. Times 10 to the 3 means kilo. Kilo means 1,000. 10 to the 3 is 1,000, actually. And so you go 12.3, not volts. Let's say that was volts. Not volts, but kilovolts. Get it? There's your engineering notation right here. I'll use this capital letters to say that really is fully engineering notation. So again, it could be a number dot number number, or it could be like this, 2 numbers dot a number, or it could even be just a 3-digit number with the decimal afterwards. But the power on 10 is divisible by 3. It has to be divisible by 3 because those are the only things that we have these special names for. So 10 to the 3, got a name for that, it's kilo. 10 to the 6th, hey, we got a name for that, it's mega. 10 to the 9th, hey, we got a name for that, it's giga. I suppose in the metric system, there's names for, like, you know, if you slide it once, it's a deca, and if you slide it twice, it's a hecto. We're not going to use those. These are the engineering prefixes, and they all are multiples of 3. Okay? So part of what you got to do then is you got to memorize all that. And I would say just sit down and memorize it, but you don't really have to do it that way. What you do is you keep this table in front of you for a while, and just from doing problems over and over, sooner or later, you're going to have this memorized. Some of it you probably know already. You may have known that 10 to the 3 means 1,000, right? Because if you had 1, times it by 10 to the 3 means times it by 10 once, twice, 3 times, you get 1,000. So kilo means 1,000. And if you have a kilovolt, it means 1,000 volts. 1,000 volt. So 2 kilovolts actually means 2,000 volts. Okay, so you can use the prefix to save yourself a little bit of extra zeros and stuff. Get that out of there. If you have 10 to the 6th, that's a million. If you had 6 zeros, that'd be a million. So mega means million. You've heard of megabytes. That would be a million bytes. You've heard of gigabytes before, right? That's actually a billion. If you want, you can say giga. I hear it both ways. Giga, giga. Giga, giga. I hear it both ways. Billion. And then if you times by 1,000 again, you get out to trillion. And we will have things that go out into the trillion. Actually, computers do nowadays, don't they? Terabytes is actually a thing these days. It didn't used to be, but now it's a thing. You can get terabytes. Man, oh man. Next, we'll have to have another prefix. I don't know what it is, but there's one out there. Anyway, if you go the other way, 10 to the minus 3, which basically means divide by 10 3 times, what you end up with is 1,000th with the TH. So that's like 0.001. If you had 1 times 10 to the minus 3, you would take the 1 and you would slide the decimal back once, back twice, back 3 times, and you get 0.001. So if you have 1 millivolt, then that means you have 1,000th of a volt. 1 millivolt is the same as 0.001 actual volts. Again, milli means thousandth. It means times 10 to the minus 3. And times 10 to the minus 3 means slide your decimal back 3 places. You end up with this, 0.001 volts. So there's a lot of, what was I going to say, a lot of logic to this. This is the way it works. This is the system right here. Micro is millionth. Nano is billionth. And pico, and there's capacitors rated in picofarads, so we need pico, and that's trillionth. So these are all small things over here, right? Millionth, billionth, trillionth, stuff like that. The main thing you want to know is you really want to know these, because those are the names, and you really want to know these, because those are the abbreviations. Notice you generally use a capital T for a big trillion, and a capital G for a big billion, and a capital M for a big million. And this bugs me. It seems to me it should be a capital K, but no, it's a small k, because we're going to be different. So anyway, that's a small k, but it's on the big side. It means 1,000. Over here we have small letters, small m for milli, small n for nano, small p for pico. And believe it or not, that's an M. See, there's a capital M, there's a small m. What the heck is that? That's a Greek M. It's a Greek lowercase m. It's called a mu. That's the way you spell it. Mu. So get used to writing that symbol, okay? It doesn't look like this. I see a lot of people try to get away with that. It's like, no, I think you've got fine motor skills by now, you know, that you can actually do this. There you go. So it's almost like making the letter U, but with a tail on it. So if you want, make a letter U and put a tail on it. But I just go like this. Oh, same thing. So that's how you make a mu. Again, if you do that, I'm not going to think that that's a mu. And make sure you don't make it look too much like an M. So you don't want it to look like an M, because it's not an M. It's a mu. Just think of a kitty cat. Mu. Anyway, so with these prefixes, now, here's some scientific notation. These are all in scientific notation, right? How can you tell? You can tell because it's number dot number number. And that's just any exponent we want. Number dot number number. Number dot number number. Number dot number number. Exponent is whatever the heck it is. That's scientific notation. If it was engineering notation, we'd have to adjust the exponents. Make sure it's a multiple of 3. So with this one, so this is scientific notation in this column. What we really want is the engineering notation. I'm not going to put it there. I'm going to start on my way. So this right now is saying move to the right 4 places. Well, tell you what, let me move to the right once. And then there's only 3 to go. Okay, so you can just, if you move to the right once, you can basically subtract 1 from your exponent because you've already moved to the right once. And now here's the engineering notation over here. It's when you put the kilo in. And notice, this is important. 10 to the 3 goes out. The kilo goes in. Let's just pretend these are all, oh, it says ohms. I'm sorry. It says ohms right there. So I might as well keep this as ohms. That's a symbol for ohms. And this will be kilo ohms. Notice, like what I was about to say, notice. Nope. Nope. Yep, okay. Notice the 10 to the 3 goes out and the kilo goes in. In other words, replace 10 to the 3rd with a little k. You have to leave the ohms there because it's a kilowatt. Could be kilovolts, kiloamps, kiloohms, kilowatts, kilowhatevers, kilomiles. Kilomiles? Anyway, so you take the 10 to the 3 out. See, this isn't quite engineering notation. It's closer, because at least I got the exponent to be a 369. But really, take that out and put the prefix in. Now you've got engineering notation. Make sure you do not simply do something weird like this. Say, hey, I got 12.3 times 10 to the 3. Oh, 10 to the 3 is kilo. Okay, you can't leave both the 10 to the 3 and the kilo, because that's saying thousand, and that's a million. Okay, you have to take it out and put the prefix in, is what I'm trying to say. Can you dig it? Hey, what are you doing? Hey, what are you doing? Hey, okay, hey, what, go back. Where was I? What? This thing can drive me nuts sometimes. Reasons. Are we in here? Oh, for crying out loud. Notability is where I want to be. There we go. I have to edit that out, won't I? So anyway, yeah. There we go. This one, what are we going to do? Well, it says times 10 to the 5th. Well, I can go to the right 2 times, and then I'll only have to go 3. There'll only be 3 left. So this is 123 times 10 to the 3rd ohms. Again, it was a 5. If I go to the right once, there's only 4 to go. If I go again, now there's only 3 to go. 123, and if you want, you can put your decimal there. 123 times 10 to the 3. Again, the 10 to the 3 means kilo, and so you would write 123 kilo ohms, and that would be your proper engineering notation. So there's 2 steps. Make the exponent a multiple of 3, and then take it out of there and replace it with a prefix. Make sure you replace it with a prefix. What do we got here? 1.23 times 10 to the 6th. Bam, it's done. Well, it's almost done. I already got a 369. I don't have to move the decimal anywhere. All I have to do is say 10 to the 6th, what's that? And you come up here and you say, oh, 10 to the 6th, that's a mega, which is abbreviation capital M. Make sure it looks like a capital M, okay? Make sure your capital M's look like capital M's, your little m's look like little m's, and your mu's look like mu's, okay? Make sure I can tell the difference. If I can't tell the difference, it's wrong, because you have to be able to read what somebody wrote for it to be readable and correct. It's not correct if you can't read it. If it's ambiguous. This one, you got this one figured out? Well, it's a 7 exponent. That's a no good. Well, I can make it down to a 6 if I actually slide once. Okay, so that's 12.3 times 10 to the 6th. Now, take out the 10 to the 6th, stick in the mega, make sure it looks like a nice capital M. If you wanted milliohms, make the M smaller than the omega, like this. Milliohms, that would be milliohms. If you want to make microohms, then you go like this. Notice the tail is kind of like beneath the line, like this, right? That's how you would write microohms. But again, this is megaohms. So I'm making a capital, maybe pointy helps, capital M, megaohms. So I think that first page pretty much gets you the idea. What is this engineering notation thing? Well, it's a lot like scientific notation, except that we're going to adjust our exponents, and then we're going to use a prefix in place of the 10 to a power. Now, I'm just going to have, I got 2 examples here. 2 examples. These look a lot like what you're going to have on the homework sheet. So being able to do these will set you up really well for being able to do the homework. So first of all, on the left, I'm giving you a formula for total resistance. Okay, I'm just giving that to you. Don will have to show you how this, where that comes from later at some point. But just trust me, if you have some kind of a setup like this, where you have these 2 resistors, we call this parallel. They're in parallel because it's kind of like you get 2 parallel paths that the flow can take. Then the total resistance from here to here, if you were to hitch up your ohm meter and measure the total resistance across both of those, it follows that formula. So let's work with some numbers and see if we can get this to work. So we're supposed to use these 2 numbers to find the total resistance. Okay, well, let's go get the calculator. What do you say? So I got to remember these numbers. I got these written down somewhere. Okay, here we are. And we're ready. Boink, boink, camera. Ooh, that's looking goofy. Goofy, woofy. That's looks like I have to turn it back on already. Boink. Okay. Now, the overall thing, looking at that formula, overall we got a big old fraction. So I'm going to hit that fraction key. Boink. Now I've got a top and a bottom zone. The top of the fraction is only a 1, so all I got to do is hit a 1 and then hit the down arrow to come down to the bottom. Now on the bottom of the fraction, we've got actually 2 more fractions. So I'm going to put a fraction key again, and this is 1 over, so the cursor's on top now. I can just hit 1, come down to the bottom. And now I need to enter the value of the first resistor, the R sub 1. R sub 1 just means it's resistor number 1. And it's given as 952 mega ohms. So you enter it this way, 952. And to enter mega, you look back at that table and you say, oh, mega means 10 to the 6th. And so remember this button from last time, times 10 to the x. And then you put the 6 in. And you've just entered mega ohms. 952 times 10 to the 6th is mega ohms. Now before you start adding anything else, notice the cursor is still in the bottom, so that's no good. You gotta hit the right arrow, get out of the fraction. Okay, cool. Now I can add another one on here, another fraction on here with a 1 on the top again. I'm coming to the bottom, and I gotta put resistor number 2. What's its resistance? It's 1.04 giga ohms. I should say one or the other, really. 1.04 giga ohms. Giga ohms. 1.04 giga. When you get to the giga, so you can't just stop with 1.04 because it's not just 1.04. It's not 1.04 ohms. It's 1.04 giga ohms. And giga means billion. And if you look at that table, it means times 10 to the 9th. So that's a very different number, right? It's not 1. It's 1 times 10 to the 9th. So you have to hit the times 10 to the x button, boink, and put your 9 on there. Boom. Awesome city. And then you hit the equals. And notice it's giving us an answer in scientific notation. It's got number dot number, and then it says times 10 to the 8th. And you go, oh, I didn't want an 8. I wanted a 3, 6, 9, 12 or something. Well, here comes your engineering button. Engineering button to the rescue. Hit it once, just once. And it says 497 times 10 to the 6th. All right, let's go back and write that down. 497 times 10 to the 6th. And again, you have to, let me scroll up, you have to go by your table here, and you have to say, oh, 10 to the 6th, that means I'm using mega. That means I'm using a capital M. So my real answer is 497 capital M mega ohms. Okay. Again, please note, that's out, that's in. It's like tag team wrestling, right? This goes out, this goes in. Take the 10 to the 6th out. Put the capital M for mega in. Do not just put mega out here. That's no good. Okay, it's not 10 to the 6th megas. It's 10 to the 6th, which is the same as mega without the 10 to the 6th. Well, while we're on this problem, actually, I want you to ask yourself something. I got 2 resistors, right? 900 mega ohms and 1.04 giga ohms. By the way, here's a quick way you can convert back and forth mega to giga and all that stuff. Let me show you this. If you want to convert from giga to mega, slide your decimal 3 places to the right. Why to the right? Well, look, it's still right. And if you want to go from mega to kilo, you'd go 3 places to the right. If you wanted to go micro to milli, you'd go 3 places to the left. It's always 3 places, 3 places, 3 places. So I'm going 1 jump to the right means I could call that. Let's see if I jump 3 places, 1, 2, 3, it would actually be this, 1040 mega ohms. Okay, so if you just want to compare things apples to apples, I got 950 mega ohms. I got 1,040 mega ohms. And when you add them together, you get what? You add 950 plus 1,000 and you get 500? What? How do you make sense of that? Well, you're gonna have to start thinking about addition in a different way, I guess. Here's the idea. And this is true, this is correct, by the way. But here's the idea. If I only had, let's try to block this out somehow. That's not blocking it out very well. So I'll block it out this way. Let's say I just had that resistor there and nothing else. This resistor again was 1,040 mega ohms. Well, guess what? The total would be 1,040 mega ohms because that's the only resistor there, right? So that makes sense. But by opening up another path, over here, see now, it used to be I only had the one resistor and you had to blow through that one. But now we've got another one over here. That's like opening up two straws. And I don't care, you know, I don't care what the resistance is of this straw. It's now going to be easier to blow through this two resistor circuit than it was to blow through the one resistor circuit. So having two resistors in parallel means the total resistance is less than either of them. And that's something to keep in mind. That's kind of a cool thing. So whenever you see resistors in parallel, the total resistance is going to be less than either one of them. This was 500. That's less than 1,000. That's less than 900. Yep, it sure is. And then how do you find out what exactly the number is? Well, you get this fancy formula that you can play with. Okay, cool. Let's do another one of these just for fun. Maybe you should try that one yourself. See if you can make a mistake. If you can make a mistake, you'll be able to learn from it. If you don't make a mistake, I guess you're not learning a darn thing. Well, no, you'd be learning, you'd be building confidence. That's what you'd be doing. You'd be saying, hey, I got it. Okay, let's see now. I have to remember these numbers. Do I have them? I have them. Let's go to the calculator. There's the calculator. Oh, why do you keep moving on me? What are you doing? What are you doing? Oh, it's this thing that keeps moving. I see. Okay, let's hit the all clear. Okay. This is a kind of a different formula. It looks like it's a big old square root of stuff. So I'm going to hit the big old square root first and have the big old square root. Now, when it says we're supposed to take the resistor and square it, the formula says R. The note sheet says R1. Who cares? It's R. It's the resistance. It's 952 microohms, but then we're going to have to square it. Now, because we're going to have to square it, I'm actually going to put it in a parentheses. I just feel safer this way. So 952 microohms. You have to look up on your table and say, what's that micro symbol stand for? It stands for 10 to the minus 6. So you come down here to the times 10 to the. Remember, to do a minus, you have to use the actual negative key, not the subtraction, the negative key. 6. Okay. Now I'm going to close the parentheses, and then I can square it. See? By putting it in the parentheses, I'm making sure that it's taking this entire number and squaring it. It's not just squaring the 6 or something weird like that. So it's just a good safety practice. Now I'm still inside the square root, and that's where I want to be. So make sure you don't want to hit this and get out of the square root, because then you'll be bumming. So make sure you're still in the square root, and then you hit plus. And I'm going to open up another parentheses because I'm going to have to square another one. This one says 1.04 milliohms. So 1.04, and remember what milli is. You look it up on the table if you don't remember, but milli is 10 to the minus 3. And so I say, okay, times 10 to the, again, minus buttons up here, 3. And then I can close that, and then that is supposed to be squared, right? Yep. So I hit the square button, and now I'm done. Everybody's in the square root. We're good. Boink. Oh, look at that. We got engineering notation right away. 1.41 times 10 to the minus 3. We just go right back here and say 1.41 times 10 to the minus 3. And then let me put a note here. Yes. Sometimes people, when they're working homework, they kind of get in a groove and they just always hit the eng button, right? If you mistakenly hit the eng button, and why don't I go do that now? I'm going to do this by mistake, okay? Watch this. Whoops! Hey, did I hit it or not? Maybe the first time you hit it, it doesn't do anything because it knows, hey, you're already in engineering notation. Let's say you hit it twice. Okay. Notice it's making it a minus 6 power. And then if you hit it again, it's a minus 9 power, minus 12 power, minus. It won't go any further because there's not enough room to put the number there. So actually, and if you want to go the other way, you hit the shift first. Shift, eng. Shift, eng. Shift, eng. And you can go as far as you want. Shift, eng. So no, 10 to the 0 means no prefix, right? Because remember, 10 to the 0 means don't move the decimal. No prefix. It would just be regular ohms. But let me go again. Shift, eng. Now I've got 10 to the 3, and that's kilo. So you'd have 0.000000141 kilo ohms. Or if you hit the engineering button again, you'd have 0.00141 regular ohms. Or if you hit it again, 1.41 milliohms. 10 to the minus 3 is milli. If you hit it again, 1,410, that would be micro ohms. So notice you can go back up and down the ladder. You can go all the way up and down the giga, mega, giga, whatever, milli, micro, and all that fun. So since the calculator will do that for you, how do you know which one that you want? Well, it goes back to what I was saying before. 3 sig figs means I only want the 141. I don't want to have anything extra. So I should actually go, let's see, I think I'm going to go backwards. So shift, eng, yeah. You stop there. So let me make this official on the notes. Just hit it again. Maybe use the shift. You might have to use the shift to get it to go the way that you want it to go. That's a parenthesis. Until you have 1 point something something. Well, I shouldn't say 1 point something something. I should say it this way. Until you have the decimal either there or there or there. The decimal, and this should not be a 0, not a 0, right? Just like scientific notation, we don't start with a 0 point something. So you should have a number dot number, or 2 numbers dot, or 3 numbers dot, and then times 10 to a multiple of 3. That's when you stop. So again, let me make this very, very clear. 5,000 volts is wrong. What you would write is 5.00 kilovolts. That's what you would write, okay? Also, 0.15, oops, 0.15, let's use amps just to be different, is wrong, or at least it's half wrong, because it's not expressed correctly. What you would do is you would hit your eng button, and it would tell you 150 times 10 to the minus 3, and then the 10 to the minus 3 is a milli. Oops, let's do it that way. Let's do it that way. Okay. When it says express your answer with proper scientific notation, that's not it. If it says express with proper scientific notation, that's not it. Okay. What you want to do is you want to do this, or maybe this, right? You want to do either number dot number, or 2 numbers dot, or 3 numbers dot. Again, not starting with the 0. Then you're in proper engineering notation. Use whatever prefix, according to whatever the power of 10 is. And I think that'll be fun. So you've got 10 of these resistor kind of problems to do on your homework, where I will always give you the formula. You don't have to memorize the formulas or anything. This is just math practice, right? You'll see these formulas in your future, I'm sure. But you can just get used to using the formula and using the calculator to get the right answers. Sounds good to me. Okay.